Okay, let us start with module 4. And this very first topic is the principle of inclusion exclusion. We all know what is the cardinality of A union B. This is equal to cardinality of A plus cardinality of B minus cardinality of A intersection B. Suppose you have the set A and the set B. If you want to count the number of elements in both the sets, that is in A union B, which is represented by cardinality of A union B. How do we count? First we start counting the elements of A. While counting the elements of A, the intersection part will also be counted. Suppose this is your set A, and when you count the elements of B, the intersection part will be counted one more time. The intersection part will be counted one more time. So this is a mistake. This is a mistake done here. The same elements are counted twice. Which are the elements counted twice? The intersection part. So we have to remove one time of the intersection part. That's why we are subtracting cardinality of A intersection B one time. Now let us see the note. Note says the cardinality of complement of A union B. That is, if we have a universal set and A union B is this, what is its complement? Complement means completely out of A and B. Complement of A union B means completely out of A union B. So this is the complement of A union B. Then how do we represent this mathematically? This is represented by cardinality of S, that is cardinality of universal set, minus the cardinality of A union B, minus the cardinality of A union B. That means from the universal set, if you remove the part of A union B, that is if you remove the part which consists of A union B, then you get the complement of A union B, which can also be written as cardinality of A complement intersection B complement. The principle of inclusion exclusion for n sets. Here we have written the principle of inclusion exclusion for two sets. If you take in general n sets, then what is the formula? Let us see. Cardinality of union of n number of sets is equal to, like here we added the cardinality of individual sets, here also we add cardinalities of individual sets, cardinality of individual sets minus summation of cardinalities of intersections of two sets in all possible ways plus summation of cardinality of all possibilities of intersection of three sets plus and so on. Finally plus minus 1 to the power n minus 1 cardinality of intersection of all n sets. See, these plus, minus, plus and so on will be taken care by this minus 1 to the power n minus 1. See, you can verify here, since here we have two number of sets. If you replace this n by 2, it is 2 minus 1, which is equal to 1. So minus 1 to the power 1 will be minus 1. Here if you have three sets, if you replace this by 3, then 3 minus 1 is 2. Therefore minus 1 to the power 2 is plus, that's why we have written plus. So this is the formula to count the total number of elements in all the given n number of sets. Now let us see the complement of intersection of the cardinality of intersection of complements of all the sets. Cardinality of complement of all the unions, which is also given by universal set, cardinality of universal set minus cardinality of the union. For example, let us take three sets and apply the previous formula. Cardinality of A1 union A2 union A3 is equal to sum of cardinality of all individual sets minus the sum of all possibilities of intersection of two sets plus this. So sign will be alternate here. See, here we have plus sign, then we got minus sign, then we have plus sign again. So this is the formula to find the number of elements in the union of three sets. Similarly, when you go for cardinality of union of four sets, first term is sum of all cardinalities of individual sets minus cardinalities of two sets, intersection of two sets plus combinations of three sets here finally minus cardinality of intersection of all four sets. So this is the formula for this. Now let us take up a problem. Among the students in a hostel, 12 students study mathematics, 20 study physics, call it as set A and call this as B, 20 study chemistry and 8 study biology. Also they have given that there are 5 students for A and B. That means there are 5 students who study set A and set B, that is mathematics and physics. There are 5 students who study both. Also 7 students for A and C, that means 7 students study mathematics and chemistry. and 4 students A and D, 16 students for B and C, 4 students for B and D, and 3 students for C and D. There are 3 students for ABC, 2 for ABD, 2 for BCD, 3 for ACD. Finally, there are 2 who study all of these subjects. There are 2 students who study all of these, and furthermore there are 71 students who do not study any of the subjects. Now what they are asking, find the total number of students in the hostel. That means they have given 4 sets like A, B, C, D. They have given the information about A, B, C, D and their intersections. We need to find a total number of students in the hostel. That is cardinality of A union, B union, C union, D. Let us collect individually the number of students who study mathematics and all other subjects. Also given that the number of students who study both A and B, and means intersection part, A intersection B means the number of the students who study both A and B, that is represented by intersection symbol. These information are given, and also for 3 combinations, the students who study A and B and C are 3 in number. Also the other information. Also they have given there are 2 students who study all the subjects, and they have given that there are 71 number of students who does not study. Complement means does not. Who does not study any of the subjects. The students who do not study A, do not study B, and do not study C, and do not study D is represented by like this. To find the total number of students in the hostel, we know that we know that cardinality of A complement intersection B complement intersection C complement intersection D complement is this. This is nothing but universal set minus the cardinality of union of all 4 sets. The cardinality of union of all 4 sets, when you expand using the formula, you will get this. Now let us substitute all the given information in this. We know all the information except few things. Let us substitute here. They have given that the number of students who does not study any of the subjects is 71. They are asking to find the total number of students in the hostel. That is cardinality of yes, we need to find. We need to find this. And they are given all other information. We have substituted here from the given data. If you simplify it further, we will get this. Again, if you simplify, cardinality of s is equal to 71 plus 29, which is 100. So we got to know there are 100 number of students in the hostel. Let us take the other example, and there is one more. Let us start with this. Out of 30 students in a hostel, 15 study history, 8 study economics, and 6 study geography. It is known that 3 students study all of these. Now they are asking us to show that 7 or more students study none of these subjects. That means they are asking us to prove none of these. That means cardinality of the students who does not means complement, does not study A and does not study B and does not study C. So this cardinality they are asking to prove as it is more than or equal to 7. So this is what they are expecting from us with the help of given data. Let S denote the set of all students in the hostel, and A1, A2, A3 denote the sets of students who study history, economics, geography respectively. That means A1 is for history, A2 is for economics, and A3 is for geography. The number of students who do not study any of the 3 subjects is given by this. That is equal to, when you expand this using the formula, you will get this. Now let us substitute the given data. They have given there are 30 students in the hostel, so we have substituted in the place of yes 30, and each cardinalities and possibilities of intersection of 2 and this they have given. Yeah, here these things they have not given in the question. This is the question mark here. We on our own we should find out what is the value of the summation. What is the value of the summation we need to find out. If you further simplify to the next step, you will get this. Further simplification will give this. Call it as equation number 1. We know that intersection of A1, A2, A3 is a subset of AI intersection AJ, because pictorially if you see, if you take 3 sets, for sure this is the intersection of all 3, can observe this is the common to all the three sets, which is a subset. If you take it as A1 and if you take this as A2 and this as A3, you can observe this intersection part, which is the intersection of all three, is a subset of A1 intersection A2, A1 intersection A2, and it is also a subset of A1 intersection A3. See, this part is the intersection of A1 A3, which is a which contains this part, which contains this intersection, and also this is a intersection of, this is a subset of the intersection A2 A3, A2 A3, you can observe. So that's why we are saying intersection of A1 A2 A3 is a subset of AI intersection AJ, where I and J varies from 1 to 3. In mathematically, if it in terms of cardinality, this set will be more than this set will be more than this, because this is a subset of this. Therefore we can write cardinality of A1 intersection A2 is greater than or equal to this cardinality. Similarly, for the other possibilities also we have the same inequality. For this also we have the same. For this also we have the same. Now let us add, because in our previous slide we wanted the sum of these three should be known. Anyhow, the RHS part of these three inequalities is known. Let us add all these. If you add, LHS will give this. If you add these three, if you add the RHS part, the same quantity is repeated for 3 times. That's why we can write 3 into this. But what is the this here? This they have given it as 3 in the question, so we have substituted 3. Therefore 3 3 is a 9 we have. Call it as equation number 2. Now we are going to use this equation 2 in equation 1 in this place, which is there in equation number 1, which will be replaced by greater than or equal to 9. Therefore substituting 2 in 1 we get, what was 1? See, 1 was this was our equation number 1. Now in this place we are going to put greater than or equal to 9. When you put greater than or equal to 9 here, this inequality will get changes to greater than or equal to. So therefore, yeah, this is your equation number 2 we have written. Now we are going to replace this by greater than or equal to 9. Let us replace. Yes, along with this equality we have written greater than or equal to 9. What is 9 minus 2 now? It is 7. So we have written. So this is what they were asking in the question. We have proved